Alright, welcome to the news. Today we'll be discussing first and foremost the most essential topic, which is that Kimi 2 Thinking is an open model from Moonshot, a Chinese company designed from the ground up as an agent that thinks rather than just writing text, planning step by step and using tools independently. In practice, it can chain between 200-300 tool calls consecutively without human intervention, allowing it to handle very complex tasks without getting lost. The architecture supports this ambition. It's a mixture of experts model with about 1 million parameters total, but 32 billion active parameters at each step. It also works with a context window of 256,000 tokens, enough to process something equivalent to an entire book in one go. It can now be used in chat mode and by activating the thinking mode with the corresponding icon, as well as through its API. Additionally, they've published the open steps so we can download and run it locally if we have the necessary hardware. The results? The numbers are impressive. In reasoning and search tests with agents, Kimi 2 outperforms models like GPT-5 and Claude 4.5 while remaining highly competitive in programming. In Human Dignity Last Exam, a tough expert level assessment, it reaches 44.9% when using tools, navigation and difficult web searches. And in the BrowseComp benchmark it scores 60.2%, well above the human baseline of 29.2%. In creative writing it also ranks high on the EQ bench, and the idea is that it repeats itself. When it can think out loud and use utilities, its accuracy scales with more tokens dedicated to thinking before answering. Let's see how it reasons. Kimi 2. Thinking alternates phases of planning, action, verification, and reflection. This is what they call interspersed thinking. After each block of steps, it reviews what's done, compares with the objective, and adjusts course. In a doctoral level math exercise, it followed a cycle of analysis, finding the key paper, reasoning, writing, executing Python code, checking for errors, and so on. And after 23 iterations of thinking, searching, and programming, it reached the solution. This same pattern transfers to code and development tasks, turning ideas into complete products by invoking tools autonomously. There are concrete examples built from a single instruction: a functional web-based word processor clone with interface, menus and rules, an interactive resource visually explaining gradient descent, a real-time simulation of a virus attacking white blood cells with adjustable parameters, even music generation through live coding in Straddle. The key is that the model not only generates content but organizes end-to-end development workflows while pursuing complex goals. It shows perseverance when solving a puzzle requiring identification of someone meeting very specific criteria. For example, training in the NFL and playing a prison guard in a particular episode. It broke down the problem, tried various tactics, changed approach when failing, and chained about 30 queries before proposing a well-reasoned solution. The process demonstrates both persistence and an important nuance. These agents, even when very powerful, may take shortcuts if they think a good enough answer meets the goal without verifying finer details. They've also refined the overall writing quality. Compared to its previous version, it now follows instructions better, handles style more fluidly, and provides greater depth. Speed is another strength, as typically when quantizing models for speed, you damage exactly what agents need: long chains of thought. Here, the team trained the system with quantization awareness to use native INT4, nearly doubling speed without sacrificing the performance mentioned. The cost approach is aggressive, but Kimi 2 Thinking is much cheaper than established closed options, roughly half the price of GPT. We offer it for $20 a month, and also, well, at a technical level too, right? Basically, in workflows with many steps, it really shines when we need it to think for extended periods and combine different actions. Overall, our conclusion is that Kimi 2 is currently an open model leading in reasoning, agent-based search, and autonomous execution of complex tasks. For us, this is the first time we've seen a system able to work for hours with hundreds of tools, maintaining focus on that continuous cycle of planning, acting, verifying, and adjusting. And that makes all the difference. Well, 3 days ago was the Tesla conference where Elon Musk and other participants presented the company's upcoming project. Basically, we're starting with Tesla Optimus. It was revealed yesterday that these robots are now real, wireless, and already walking around the engineering headquarters 24/7, returning to recharge on their own. Elon Musk explained this from his office, and the ambition is enormous. Optimus was positioned as the biggest product of all time, with both personal and industrial demand, 3 to 5 industrial units for each household unit, potentially reaching tens of billions in sales. Safety and creating a desirable future were emphasized. The production plan envisions a first production line for 1 million units in Fremont, then scaling to 10 million annually, and eventually reaching 100 million per year. It was stated that Optimus can drive a much larger economy, enable high-precision medicine more accurate than the best human surgeon, and eventually allow services like surveillance and more. 3 challenges were identified that almost no one solved simultaneously: the hand, the forearm, and artificial intelligence applied to the real world and mass manufacturing. Tesla claimed to master all three, and the current Optimus line is handcrafted for prototype. The high-volume production will be fully automated with a stable output of around 1 million units per year. Costs would drop to a level that would be affordable on schedule. What was shown is version 2.5, and version 3 will arrive next year with a major leap in design and capabilities. Version 4 enters production in 2027, and version 5 in 2028. The historic goal of accelerating sustainable energy toward abundance was updated, envisioning a future where everyone accesses goods, services, and healthcare without harming nature. Within this framework, all Teslas are designed for autonomy, and version 14 reaches a point where messaging while driving could be allowed, if safety statistics remain positive. Currently, drivers must still watch the road, and this policy will be re-evaluated after reviewing data in 1 to 3 months. They're also introducing the Cybercab Robotaxi, a vehicle without pedals, steering wheel or mirrors, optimized for lowest cost per kilometer. Manufacturing is scheduled to begin in April next year. The production method resembles consumer electronics more than traditional automotive manufacturing. Additionally, they have some development underway on artificial intelligence chips. They unveiled the custom-designed AI-5 for Tesla's networks, with estimated power consumption at 1/3 of NVIDIA Blackwell, comparable performance and cost under 10%, achieved by focusing on inference with integer operations without general compatibility overhead. Manufacturing is planned in Taiwan, Samsung facilities in Korea, Arizona, Texas, and they're already developing AI-6, aiming to double performance in less than a year on the same process. Even with external suppliers, they still can't meet demand. That's why they're considering building their own colossal scale facility, a terafactory for chips, including memory and packaging. They highlighted that chips and energy remain the main bottlenecks. They also showcased various models, S3, X, Y, and the Cybertruck, highlighting its durability and other features. Several goals were set, stating that with reliability exceeding human drivers in automated driving, it's time to accelerate manufacturing with a target of growing around 50% by the end of next year, reaching an annualized rate of 2.6 to 2.7 million vehicles by the end of that period. It's also possible to reduce cost per kilometer below 0.20 in current terms with significant effort. Below 0.50 would be very good, and around 0.30 was considered ideal in the calculations discussed. They proposed using parked cars as part of a distributed computing network with owner permission, generating passive income. They mentioned an indicative monthly figure and building massive distributed capacity as the fleet scales with future chips. Finally, the central idea is that we're seeing a new chapter for the company, with sustainable abundance as the goal, autonomous driving safer than humans saving lives, an accelerated deployment of robots and energy that transforms economic scale. Alright, today we're discussing a turning point. At the 2025 shareholders meeting, Elon Musk highlighted the new capabilities of Optimus Gen 3. It's no longer just a concept, it's walking through Tesla offices, self-charging, and performing human tasks precisely. From folding clothes and handling kitchen utensils to collecting and sorting trash. It cleans surfaces, moves indoors wirelessly without an operator, and handles delicate objects like eggs or popcorn kernels. It's also demonstrated body control with martial arts movements, showing advanced balance, and was even seen dancing during the conference. This strategy builds on a fundamental idea: humanoids performing most physical work cheaply and continuously, causing the cost of goods and services to plummet. The approach discusses sustainable abundance with a potential tenfold increase in the global economy, making basic necessities more affordable and reducing poverty. Regarding capabilities, they emphasize that the robot learns through observation. Tesla's approach applies its autonomous driving neural network philosophy to the robot's body, enabling it to see, understand, and execute in one unified flow, trained with first and third person video and using simulation for rare or dangerous scenarios. This method has enabled rapid progress. The robot folds clothes skillfully, applies gentle force to avoid breaking eggs, and sufficient strength to handle heavy objects, all functioning in real-time automated operation. In hardware, they've stated the biggest challenge lies in the hand and forearm. It's described as the most difficult electromechanical component of the entire project. The goal of human-like dexterity requires pressure and touch sensors on each finger, real-time force control, and many degrees of freedom. The announced Gen 3 configuration features 22 degrees of freedom in the hand, 3 in the wrist and forearm, totaling 25 per hand, with fingers that can apply adaptive force to objects. Due to the manipulator's complexity, several revisions have been necessary. Overheating issues and extended cycles forced a redesign of the actuators, coinciding with the departure of the robotics lead who oversaw mechatronics. Tesla frames this as an engineering review phase, but markets interpreted it as a sign that mass production still needs further iteration. In the release schedule, the robot shown in 2025 was described as version 2.5, with plans for Gen 3 production in 2026, Optimus 4 in 2027, and Optimus 5 in 2028, featuring annual improvements in mechanics, materials, and AI software following smartphone-like production cycle. Additionally, integration with Neuralink is planned, as the company has already demonstrated brain-controlled cursor movement in humans and aims to bring this control interface to Optimus. The concept is that you won't need to control each joint or think, grab the cup or store the bot. Instead, the chip will read your intention, the AI system will generate the plan, and the robot will execute it while adjusting trajectory and force. They also mentioned the goal of bidirectional feedback, allowing users to enter the robot's body, see through its cameras, and feel pressure, temperature, or vibrations through the interface. The possibility of transferring aspects of consciousness to a robotic body in future decades has even emerged as long-term speculation. Meanwhile, the first practical approach is disability assistance through remote control and sensory feedback. The economic positioning is strengthened by the target cost of $24,000 per unit and a selling price between $20,000 and $30,000. Critics argue the real cost is much higher, potentially by orders of magnitude, which would significantly limit the market. The project responds that mass production and vertical integration should reduce costs over time, with goals to eventually lower prices to $10,000 per unit. The plan leverages factories ready for high volumes, integrating batteries, electronics, and proprietary computing, established supply chains and expertise, reducing costs in sectors like electric vehicles. Regarding Optimus, the plan isn't just about manufacturing, but integrating it into Tesla's ecosystem. In summary, we're presenting a robot that autonomously navigates Tesla facilities, learns through observation, handles both fragile and heavy objects on the same platform, and aims for production in the millions at an aggressive target cost. The goal is to accelerate towards sustainable abundance through automated physical labor by solving hand dexterity, advancing AI in unstructured environments, and scaling up production. Meanwhile, other players are raising the bar in natural movement, human interaction, and specialized applications. What will determine success is the ability to convert numerous actions into daily operations, maintain yearly iteration cycles, and meet the proposed cost and volume targets. Alright, today we're going to discuss a fundamental challenge of current models: catastrophic forgetting. This phenomenon occurs when a system learns something new, and in doing so, loses accuracy in what it already knew. And what we see in today's models is that yes, they can be retrained, but they lack the ability to continuously incorporate new experiences without breaking previous knowledge. They continue to function as if erasing their previous state to readjust everything from scratch. For years, we've seen enormous improvements in architectures and optimization algorithms, yet this issue remains unsolved, because memory in these systems is limited to what was fixed during pre-training and what fits in the context window during each use. There's no solid gradient between distant past learning and what's happening in real time. When we compare this to the human brain, we find a clear structural difference. Our brain has different updating rhythms and neuroplasticity, the ability to adjust each part at different speeds depending on the type of information. Thanks to this, we remain anchored in the present moment. If the brain lacked this ability, it would be like living in a state similar to anterograde amnesia. What's surprising is that LLMs behave very similarly in this extreme case. Either they remember because they memorized it during training, or they only exist in that moment without real consolidation ability. In the proposal we're analyzing, Nested Learning from Google, the idea presents a model not as a single optimization process, but as a structure of multiple learning processes organized in levels, each with its own update frequency. Instead of a flat stack of layers all learning at the same rate, the proposal envisions it as integrated systems learning simultaneously but at different speeds. In this view, architecture and parameter tuning aren't independent concepts. The proposal states that both form a single system. Models, layers, attention, feed-forward, even the optimizer itself. All are associative memory mechanisms adjusting their internal state based on data novelty. This interpretation makes everything a transparent system, no longer an external process operating on the model, but part of the model itself. This opens the door to reinterpreting known improvements as forms of associative memory, including strategies like normalizing optimization space, preconditioning gradients, or introducing non-linearities in the update path. On the architectural level, this translates into a proposal called a continuous memory system. This system defines a set of blocks with different update frequencies, creating a spectrum beyond just long-term or short-term memory. One block updates at each step, another every few steps, and others at even wider intervals. Based on this, they've developed a model called HOPE, built on a memory-loaded design called Titans. Titans already handled long-term memory, but only with two frequencies, fast and slow. HOPE extends this to an open chain of layers that can have as many learning scales as needed. In other words, it's not limited to just two. This design allows a model to refine not only its representation, but also how it changes its own learning approach. This means it self-adjusts its own update algorithm and not only manipulates weight, but also modifies how those weights are updated. The result is its own feedback loop. In language task tests, perplexity measurements, and reasoning evaluations, This design has shown advantages over standard tools by eliminating the historical separation between model and training algorithm, proposing them as a single structure. For us, this means trying to close the gap between rigid systems and those that retain experience like the human brain. We're not talking about simply expanding capacity, but about a system where different parts learn at different speeds to preserve prior experience without losing adaptability. Although this research is just beginning, initial results suggest this could be a real step toward models that don't just accumulate parameters, but can continuously modify themselves without erasing what came before. Alright, let's start with Gemini and its Canvas feature for presentations. Now we can ask it to create presentations as we're seeing, and export them directly to web slides with just one click. For example, if we request a presentation about the impact of AI or any topic, Gemini will activate Canvas and generate a document with multiple slides. There's also a practical workaround when starting with PDF. If we upload a paper or report and directly request a presentation, it might respond that it can only process text and can't help. However, if we first ask for a PDF summary and then in a separate conversation request a Google presentation based on that summary, we can generate it that way, okay? Also, on another note, we have we have deep research within the Gemini chatbot, which Google has expanded. And besides searching the web, it can create reports by accessing our email and Google Drive documents right in the interface. When activating in-depth research, we see options to upload files and select sources, where we decide if we use Google search results, add Gmail with Drive, or focus on just one source. We can enable all sources or just a few, but you always need at least one search source to generate the report. This source control lets us adjust the scope, web only, Drive only, combined with email, or even including the chat itself as a source. Now let's look at Notebook LM, where its utility multiplies through the variety of formats it now processes. Beyond PDFs, it can now work with spreadsheets uploaded from Google Drive. This opens the door to cases where data lives in tables. For example, a spreadsheet with nearly 2,000 records. When you add it, you might see a warning that the source is empty, as if there's no content, but it will still appear in the preview. In practice, despite alarming messages when uploading the source, it still provides useful analysis. The most powerful feature is combining this data with text from other sources to create more relevant materials, like reports or video-audio summaries within the studio. Another helpful detail in the studio is that we can retrieve the customization prompt used to generate each element. In new generations, the show request option appears, letting us see exactly what instructions we used to create quiz cards or video summaries. If something didn't work particularly well, no need to memorize it. We can simply retrieve and reuse it. We also have the Flow video model here, which basically concludes with Google's video innovation. They now allow us to control the camera in VO3 within Flow. The idea is simple yet powerful, right? In an already generated video, we can adjust the camera position or movement. In the demos, you can see a shot of a person where we can orbit the camera, changing between different angles. These updates give us three clear advantages: faster presentations with well-edited slides, expanded research capabilities for emails and documents with source control, and tabular data analysis in Notebook LM, plus camera control for existing videos to refine the narrative. All of this is ready to implement with the steps we just reviewed. There aren't really any major breakthroughs or completely new features, right? After all, camera control is something other models already offered. Presentation features are quite interesting, and the Excel upload capability is valuable too. Okay, we're going to be talking about Kosmos, and this, what exactly is it? Well, it's not a chatbot or a code assistant. Basically, it's a system designed to conduct science from start to finish without human intervention, developed by Microsoft. We give it a goal and a dataset, brain scans, genomics, or materials, press start, and for 12 hours it focuses exclusively on research. During this time it reads about 1,500 articles in sequence and writes around 40,000 lines of Python code in a typical session, runs analyses, tests, hypotheses, and produces a complete scientific report with references and executable code. How does it maintain long research processes without losing focus? It's not a single model doing everything, but coordinates hundreds of specialized agents. Some read and condense literature, others plan and analyze data, others program and test, and others share structured memory. It's a world model that records what was tried, what worked, and what still needs validation. In practice, it's a digital lab where all parts communicate and update continuously. The initial results weren't just simulations. Kosmos has produced real findings in biology, neuroscience, and materials. For example, when studying temperature drops in the brain, he found neurons shift metabolism to nucleotide recycling pathways to save energy. Similarly, when analyzing perovskite solar cells, he discovered excessive humidity during heating damages devices and linked solvent partial pressure to current drops, a pattern humans hadn't noticed in the data. In brain connectivity, he compared data across species from insects to humans and concluded connection organization follows log-normal distributions, with quantitative relationships between neuron length and synapse numbers that remain consistent across species. In cardiology, they linked the SOD2 protein with protection against fibrosis, with findings that matched almost exactly with human analyses. In diabetes genetics, they prioritized variants using their own mechanistic criteria, and identified a specific variant associated with a gene involved in cell stress and insulin response. For Alzheimer's, they applied segmented regression analysis on cellular pseudotemporality to pinpoint when neurons begin losing structural support after toxic protein accumulation. Beyond these examples, the scale of work is impressive. A single 12-hour block produces what would take human researchers several months to accomplish. Independent experts reviewed the reports and found roughly 8 out of 10 scientific claims to be accurate, with documents resembling early manuscripts complete with graphs, statistics, and citations. The experience is similar to reading a novice researcher, except this one can run hundreds of experiments in succession. However, it's not infallible or all-purpose. Its best results came in a range of topics with scientists in the loop. People define goals and data, Kosmos does the hard work, and then humans decide what deserves follow-up. It struggles more with messy or unlabeled data. It doesn't accept mid-process instructions and currently can't handle huge files over 5 gigabytes or unusual data formats. The key bottleneck is judgment, distinguishing what's truly significant from what's merely statistically correct. Even with these limitations, it marks a turning point as we're seeing autonomous research with verifiable results for the first time. Under the hood, there are 2 ideas that give it solidity. The first is shared memory, which prevents forgetfulness and unnecessary repetition across hundreds of steps, and the second is traceability. Each claim in their reports can be traced back to the code that produces it, or the exact passage in literature supporting it. It's not a black box. You can open each thread and see how it reached its conclusion. So, the essential thing is the change of pace. Literature reviews that once took months now finish in hours, and projects that required years are compressed into months. They don't eliminate scientists, they empower them. We set direction and validate. The system handles reading, programming, and testing at scale with step-by-step transparency within understood limits of data size, control, execution scope, and need for human judgment. We're already seeing a work method where AI doesn't just assist the process, but becomes the discovery process itself. So what do you think about this tool presented by Microsoft, Kosmos, and especially all its results, right? Alright, today we're going to discuss findings from ChatGPT's backend, where direct references to model names like GPT-5.1, GPT-5.1 Pro, GPT-5.1, reasoning, and others were discovered in JavaScript code served from OpenAI's CDN. These names weren't in external discussions, but within endpoints and maps in the site's code. When named references and variants appear there, it typically means they're being tested internally or are close to public release. This appearance in the actual code is what triggered this reaction, and we're not talking about speculation or support, but actual strings and values found in real code bundles. These strings also include a date pointing to November 24th, as confirmed by Mark Kreshman. This date might be internal, but the fact that it's coded there does link the model name and has led many to assume it's happening soon. What makes this finding even more interesting is the term thinking, as the name GPT-151 5.1 thinking appeared alongside other variants. This term suggests that this potential model wouldn't just focus on faster generation, but on applying more multi-step reasoning to break down problems and execute something closer to deliberate planning. It's been suggested this thinking feature could incorporate reasoning budgets, allocating more compute time to difficult problems, just as humans pause longer before answering complex questions. It's also been suggested that there would be improvements in handling ambiguous contexts as a form of evolution, as we've seen models with enhanced chains of thought, but all of this is clearly speculation. Alongside these internal references, another element has raised even more suspicion. The anonymous model called called Polaris Alpha, which has started appearing on OpenRouter. Many people began testing it because it seemed to outperform GPT-4 class models. And then it was noticed that this anonymous model only appeared there, similar to previous OpenAI variants that first emerged disguised on that same platform. Additionally, Polaris Alpha demonstrates creative and reasoning capabilities that cluster very closely with GPT-5 and GPT-5 Mini in benchmark analyses of writing tasks and other metrics. Another indicator was its speed and usage limitation. The extremely high limits Polaris Alpha has on OpenRouter don't typically align with small research releases. The visual style it produces for UI generation also resembles the aesthetic that has become common in recent OpenAI models. Another piece of context is that during this same period, codex efficiency improvements were announced and usage limits were increased for Plus, Business, Education, and Enterprise, noting enhanced GPU performance. This was interpreted as possibly freeing up resources for other internal use, fitting the hypothesis that another model line was ready for test deployment. Additionally, that GPT-5.1 Pro reasoning-based chain in the code resembles the structure that existed with GPT-4, which had turbo and variants with different capabilities targeted at specific tasks. Another detail was when prompts were executed and responses showed the model identifying itself as a large model from an unknown provider, while mentioning a string matching the typical knowledge cutoff date of a recent internal OpenAI model. So, if we connect the exact references in the official code, the appearance of Pro and Reasoning variant names, the late November date embedded in the site, Polaris Alpha's benchmark behavior, the generation style matching recent models from the same line, and its exclusive presence on OpenRouter, as happened before, everything suggests GPT-5. One is being tested and some users are already using it unknowingly. Therefore, what we're seeing indicates GPT-5. One isn't baseless speculation. The names are in the code, variations are listed, behaviors appear in real tests, and the pattern matches previous deployments. So anyway, let me know what you think, and if you're interested in the GPT-5. One launch which is just around the corner along with Gemini 3. Let's see what happens.